Good afternoon, everybody. I'm glad you could attend my talk. I know it is getting late in the day, and you're probably getting a load of information. So I like to kind of keep this lighthearted, informational, and just have a good time. Please, there's going to be a section for question and answer at the end. But if you have something that you really want to ask, by all means, raise your hand. I'll try and address it. We only have a certain period of time, so I want to make sure that we get through the presentation. As was communicated in the introduction, the topic of the conversation is, could a few lines of code it all up? And this is kind of looking at some aspects that you may not be thinking about when you start developing in open source. So more than 90% of commercial applications make use of open source software. Open source software is great, but you're always concerned about what you don't know. And I'm going to get into that a little bit more as we start the conversation today. But one of the major open source packages that people are using, Node.js, is quickly becoming a leading framework. But there's some issues with the repository and the way that it's being used and communicated and downloaded by the consumers of the technology, if you will. So I do not know how to totally pronounce this person's name right. I take a guess. Azir Kakulu is what I'm going to go with. Anyone have any other alternative spellings or pronunciations? No? You can get creative if you want. Well, there's a story associated with this. This is a fairly anonymous developer that decided to liberate his modules following a disagreement with Npm staff. Who knows what Npm? We're going to talk about it, but who knows what Npm is? Very good. So he got into a fight with Node Package Manager and said, fine, I'm taking my ball and I'm going home. His ball being his code. I use his ball as an example there. He takes his code and goes home. Among them was a module named leftpad. OK, he takes his code. How does that affect other people? How does that basically maybe hurt, as was mentioned, some of the major organizations in the world? This obscure developer nobody's ever heard of takes his code and goes home, and there's huge ramifications. When somebody was trying to use a package, leftpad was a dependency. And it would cause things to go awry. If you can see, you get all sorts of error messages. It's missing leftpad. It's gone. It's no longer a dependency that the code that they're trying to use is looking for. So highlight this, and this is where we're kind of going with this conversation. Leftpad is not in the NPM registry. You should bug the author to publish it. Well, you can bug him all you want. He took it and went home. Or use the name yourself. Anybody know the ramifications of that and the way NPM works? It's only the name is the identifying piece. So if somebody else wanted to upload into NPM something called leftpad, everything would then just consume that. There's no versioning. There's no specific mapping to something else. So somebody else could basically just say, oh, it's gone. I'm going to put it in there. And they could put whatever code they wanted in that piece of download. Very, very dangerous in the concept. So what this really did was, leftpad was used by over 40 NPM modules. So immediately there were 40 modules that people were using, including the two parent of React and Babel were used by Facebook and Airbnb and many others. These apps just broke. They started to look for that missing component, and they broke. This actually triggered a very conceptual, interesting conversation about how can this guy just take his code? He put it out there for use as part of an open source package, and it's gone. How can this happen? Should an author be able to unpublish his work without a process? What happens to the available module names? Again, everything is mapped by their name, and if somebody takes it out and it's gone, somebody could jump right in there and put the same name in there. So you don't know what you're getting sometimes. You have to be very cautious about the dependencies and the availability of the code. Now we'll talk about the Npm platform. As was mentioned, the Npm platform, as in the upper right-hand corner, Npm Node.js Package Manager. It is primarily the main point for managing of open source packages associated with Node.js. You can find, share, reuse packages of code from hundreds of thousands of developers, and there's around 300,000 modules available. It's a lot of code to choose from, a lot of things you don't have to do yourself. Why do you want to reinvent the wheel when somebody's already created the wheel for you? Much easier to use somebody else's work as long as it's tested, as long as it's used appropriately. From thinking about this too, around 100,000 of these modules have no dependencies. They are what they are. However, 200,000 of them actually have dependencies. Some of them have many dependencies. One of the biggest numbers we saw in our research are single modules that have more than 80,000 dependencies. You got to think about that. That's complexity. Complexity. We're going to give some examples of you may not perceive how many dependencies are actually happening when you download A. There's B, C, D, E, F. There's many different modules that basically could be dangerous. And we're going to talk about how this can be dangerous. One of the things to point out about NPM, semantic versioning. NPM really suggests and uses semantic versioning. The example on the bottom really gives you kind of a comical look at the caveman is now the super robot. If a dependency is just inherited, there's no control over that. So dependencies are not locked to a certain version by default. For any dependency, the dependency author can push a new version of the package. That's great. Keep it up to date, add new features and functions. However, they may add things that you haven't tested in your applications. You put that into a production app, they push it, you don't even know. You just are using the application, you assume everything's the same. They publish a new feature function, that may cause something to work inappropriately in your application. So really be cautious about that, and I'll talk about some ways that you can prevent this in a couple minutes. One of the other things, and this is a real security risk, NPM has persistent authentication. You are not logged out until you manually log out. So you open up the NPM connection, you download a bunch of modules, you're using it, and you go to do something else. How many people lock their laptop every time they leave? Be honest, every time? I see like probably 10%. You know, I'm a victim of this too. You get up, you leave, maybe it's only a couple minutes, you're with colleagues. If you're logged in there, somebody could go in and change something and upload it to your NPM registry. It's possible. You're not logged out. You go and you leave your laptop, maybe someone else has even if you lock your machine, one of your co-developers has access to your machine, has your login credentials, they could go in and publish something under your repository, change one of the things that is a dependency that you wrote. This is a very, when you're using this in a commercial world, this is of concern because you don't know what is going up. You're just basically, you're taking the reviews and the recommendations of other people, kind of the word of mouth aspect, but this is definitely a risk. This is something that's a real risk within NPM. It's a centralized registry. That means NPM, tongue tie, NPM utilizes a centralized registry. Typing npm publish ships your code to the registry server, where it can be accessed by anybody. Very easy to do. I have like a automated demo that shows you how simple it is. It basically publishes it, and then anybody can download that. And if it's a dependency, it's going to come down as part of that package. Let's take an example. This is just something to think about. How many people actually are using NPM today or using Node.js? I had one, a few. This is, and especially if you're not actually a developer and you're actually managing teams, this is something you should ask your teams. Think about this. So, for example, there's a package called Active Directory. It's for authentication, pretty much LDAP authentication for auth-n and auth-z. It had around 13,000 downloads last month. This is this presentation that might not be up to date with last month. When the presentation was created, that was the actual number. It's a lot of downloads. And then to think about it, it has 4 dependencies. That's what it lists, 4 dependencies. You think that's the actual value of dependencies it has? This is where the scary aspects of knowing what is in your code really happens. 4 dependencies. If I click this, this is the install. It's a little animation here. This will work for me. It doesn't work in slide presentation. Well, this is an animation of the download. And basically, all this chunk of data pops down. And there's a big chunk of data. You don't understand what it is, but hey, it works. It seems to have worked. It's in there. So this little interesting math, 4 plus 10 plus 4 plus 1 equals 19. Query of the audience, what do you think that means? Well, we know there's 4 dependencies. There's our 4 dependencies. Build correctly for me. There you go. There's our 4 dependencies. And this is going to go quick, and we're going to talk about one of the dependencies. Each one of these dependencies has multiple dependencies. One of the dependencies is this very unique small file called Lodash. Anybody know what Lodash is? It has 82,000 modules that use this. So we'll do the same thing. 30 million downloads because of all the dependencies that use it. It has 0 dependencies. So it's consumed. It doesn't actually consume anything. And it has 82,000 dependents. So think about that previous example with leftpad. Imagine if this one was taken out. How many modules, how much code in the world would break if this was removed? And again, with the concern about when you're the persistent login, the semantic versioning, all that really takes effect on many different types of application. So again, a couple lines of code really could mess everything up. Because this is a couple lines of code. This is Lodash. That's all it is. Looks pretty important. Not that somebody couldn't do this by themselves very, very quickly, but that's all it does. So if somebody was to take this piece of code, this Lodash out of NDM, it would cause a lot of havoc for a lot of companies. So a couple lines of code could really mess everything up. Questions up to this point? See a lot of head shaking. And we already talked about 90,000, 89, 90. 90 is a bigger number. Everyone gets impressed by bigger numbers. So let's look at some potential scenarios. You could create a useful module. Do some good old marketing. Push your module. Make it sound like it's the best thing since sliced bread. It does the most amazing computation. It saves you time. It does all these things. It gets a mass adoption, like Lodash. And then you update it. You change it for maybe your own personal gain, maybe financial gain, maybe you just want to mess with people, but it is possible. You could create a module with a similar name. There was a security researcher that had a research project. They uploaded, there is a module called CoffeeScript, COFFEE-script. They uploaded COFFE-script. They just changed the name a little bit. One letter, tons of people downloaded it thinking it was the actual CoffeeScript. You have to make sure you know what you're downloading. It was a widely successful research project by a security researcher on how to potentially leverage NPM. Taking over control of a legit account. Somebody walks away from their workstation, you know what you're doing, you know what you want to upload, you know what the name of something is. You could very easily take over a legit account and publish dangerous code, questionable code, insecure code. Now we go, that was malicious, someone actually trying to do something. Now we can go to careless. So again, thinking about the inheritance of the dependencies and how far down the chain they are. So everybody take a look at this block of code. I know everybody's maybe not a coder, but think about what would be potentially the vulnerability in this block of code. Any comments? Any ideas?
Null byte in the middle of the URL somewhere?
Yeah, it's a potential denial of service attack. Because you're checking for that loop with the null byte, but you're not checking for any type of size limitation. So we're going to talk about this. And this is kind of where we found some of these issues. I'm going to talk about some other ones. We basically download the top 50 popular packages and the top 50 dependent upon packages. So something that people are downloading a lot and the dependencies that are being consumed by the popular packages. And some other packages that we thought were pretty cool. We analyzed the results. We performed responsible disclosure to the developer, because all that information is there, told them what vulnerabilities were happening, waited for a patch, and then published the data. This is where the interesting part happened. So here's an example of what we did. One of the things that's interesting, though, if you see here, here's some of the packages we scanned. When we scanned them, the LOC is the lines of code. Some of these are very small. We contact the owner of the code. It's a couple lines. We saw what Lodash looked like, a couple lines of code. You could fix something in there really quickly. Some of these are large. Look at Lodash. It's 128,000 lines of code. So to find the vulnerability in that code is going to take some time. Even if you communicate the right information, it could take a lot of time for that vulnerability to be fixed and for the information to be published and everyone to be happy. So consider the complexity and the size, the raw size of these applications can sometimes delay the process for an accurate remediation. So again, here's the code snippet. We were able to, with our platform, identify a denial of service attack based on that null byte. There was another package that we downloaded, Node Static. It has a very, very large 12,000 downloads and this is not yesterday. This is when the presentation was created. 12,000 downloads, 66,000 downloads in the last week, 278,000 downloads in the last month. 369 other packages are dependent on this. And this had the same vulnerability. You can see, very similar to that other vulnerability we have found. OK, so we tried to prove it. We sent a load, checkmarks.com, with the null. And we reported it to the developer. He said, I don't think it's a bug. Not a bug, not worried about it, it's not a bug. We said, we think it's really an issue. Nope, don't bother me. OK. With a 22 KB payload, we had a 1-second lag, 35 KB payload, a 3-second lag, and an 86 KB payload, the server crashed. This is where it gets interesting. So if we go back a couple slides, there are 369 other packages dependent on this. 369. So when we showed him the results of the payload, he said, oh, OK then. This was just basically for an old browser anyway and just commented it out. These are the things you have to be concerned about. So the vulnerable code wasn't even real code. I think it was, yeah, we put that in there for an old browser. Nobody uses it anymore, so we'll just comment it out. Uploaded it, and then the payload, it actually fixed it. We also found, this one's not published yet, so I can't tell you who it is. But we also found a command injection. And the variable input was used as an argument for an OS command. The flaw exists because the original author used it. A possible solution, just delete the file. It's still in there. He hasn't fixed it. But his fix was, that's somebody that's not here anymore. We don't really know what it does. Just delete it. You should be good. These are the things you have to, this is carelessness. Code that's just kicking around, especially with the complexity of the dependencies and dependencies of dependencies. You have to be aware of what code you're using. Open source is not, it's easy. I'm not reinventing the wheel, but you've got to understand the security ramifications of just taking what you consider a very popular, again, popular package. This was one of the popular packages on NPM, but these were issues that were actually found. Some other interesting things that we found in these popular packages. Command injection, stored cross-site scripting, denial of service by loop, denial of service by regex, CSV injection, insecure randomness, and open redirects. These are things that are out there right now that are being used in major commercial applications. So how do you protect yourself? Verify the dependencies of the dependencies. When it says, again, we had that little exercise, 4 dependencies for that package. It's actually 19, because the dependencies have dependencies. What happens if one of those vulnerabilities propagates itself? What if Lodash has that vulnerability and propagates itself to tens of thousands of applications? Inspect the code. You can download the code, take a look at it, manual review, static review. Inspect the code before you use it yourself. Don't allow these to execute automatically. npm install, ignore scripts. Don't allow it to automatically install. Use npm shrink wrap to lock down your own dependencies. This is so you control them. If there's an update to the dependency, you're not basically just taking a new dependency that you haven't tested against. You have a snapshot in time of a version that actually works. Sometimes it's better to write your own functions. Lodash was this much code. If you really needed that function, how long would it have taken you to write that much code? I mean, honestly, how much time are you saving yourself? And it's yours. And it's not at the whim of somebody else to possibly change. Analyze your code, but your code includes your dependencies. Again, I'm really harping on a point. Be careful of dependencies. Be careful of the unknown or 3 levers down that you've never even considered. Last one is, once you're logged in, log out. Because again, it's persistent. If you don't log out, anyone else can access the system. Some other examples, and these are, you can actually run your own npm repo. All this research we did, we just downloaded everything and ran our own repo. We were separate from the main registry server. So if there are any updates, there are any changes, we knew exactly what we were testing and how to use it. And prevent installing from the main registry. So those dependencies, if something is just arbitrarily pulled down, again, the name, there's no version. If it's a dependency, it'll just come directly down. Make sure that you're aware of this. How many people are using open source code right now? There's a lot of hands. That's what I was looking. There's a lot of hands. So this is something that's probably on your mind. Are you using anything that's concerning to you? Are you doing any testing on your open source code? You can raise your hands to that too? No? Right in the front, yes. It is a concern. It does save time, but it also introduces risk that is unmanaged risk, especially with the concept of inheritance and dependencies. We are a static analysis company. We basically have research projects on pretty much anything, so always want to be on the forefront of testing, all different types of open source packages. Node.js is just very popular, so we make sure that we want to help extend the information to the people that are using the technology that there are risks. Is that it? Well, I gave you back some time. It wasn't a long presentation, but sometimes there's a ton of questions, and I get really beat up at the end, so I appreciate you guys being kind to me.
All right, thank you, Matt.
Thank you.
And as a sign of appreciation, here's a Lascon zippered hooded sweatshirt.
Thank you so much.